All right, welcome back, everybody. So the last lesson, we learned some climate control factors. Um, Quick review of that. If you remember latitude's control factor is that as you travel farther north or south away from the equator, things get colder. That has to do with the angle of the sun's rays as it strikes the earth. It gets lower and lower and lower as you travel towards the poles, spreading out that energy. We also learned how elevation controls climate. Higher you go in the troposphere, which is where we live, the colder it gets. And so if you live on a mountain, it's colder than if you live in the valleys, on average. We learned that if you live near a large body of water, your temperatures are more moderated. They're more even throughout the year and throughout the day. We learned that prevailing winds, if they blow off the water to the land, they bring not only more moisture, but more moderated temperatures. We learned that if you live near a warm ocean current, for instance, like the Gulf Stream, it modifies your temperature, makes it more moderated and warmer, more moist. And vegetation, or the lack of it. We learned how if you cut down large swaths of vegetation like rainforests, it can drastically alter the local climate of an area, making it drier and warmer. Today's topic, though, is even bigger. Large-scale climate altering factors. These are things that can possibly change the climate of the entire planet. And let's start off with El Nino. Named after the Christ child, this is an event that occurs and usually shows up near Christmas time in South America, coast of Peru. And what it is basically a disruption in Pacific Ocean atmospheric relationship. Happens every 2 to 7 years, and it results in altered climates worldwide, mainly in Australia, South America, North America. Like I said, it's first noticeable in Peru. And if you look on this left-hand picture here, this is a normal condition. And in the normal conditions on the equator, and you'll see this in your reference tables on the global wind currents map, planetary winds map, there's normally a west wind that's blowing at the equator, and that's keeping the warmer surface waters of the Pacific out in the western Pacific and the associated rain that forms from it in the western Pacific. That also helps to draw cold water, nutrient-rich water, up to the west coast of South America, and it really helps out those fishermen on the coast. You get a lot of good fish because of that cold, oxygen-rich water. Well, every 2 to 7 years, this west wind kind of dies down, and we get this drifting effect of these warm surface waters towards the east, and that changes the circulation pattern in the Pacific, and it changes where the storms occur, and it moves the jet stream around. You'll notice that the cold water here is not upwelling against the coast of South America. It's kind of staying down deep. And so those fishermen really lose out on a lot of income, livelihood. And this affects our weather. It makes our winter time a little bit more mild. It can cause rains in the southeast and droughts in the western United States. It causes droughts in Australia. So there's all kinds of things that happen from this, but it's natural. It's not anything we can control. The opposite of El Nino is La Nina, and that's, instead of a west wind drift like normal, it's a really strong western drift of wind, pushing those storms way out into some of those Pacific Island nations. Now this whole thing does go away. It lasts about a year or so, and then it goes away, and then it comes back again. So that is the basics about El Nino. There's a lot more to it, and I'm sure there's a lot that I don't understand about it. One positive thing about El Nino for us is that it shifts the jet streams around in the United States enough to kind of shear off the tops of a lot of hurricanes that try to form in the fall. And so we actually have a mild hurricane season when there's a strong El Nino. So that's a good thing. It's just a close-up showing how the Pacific Ocean changes during normal conditions versus El Nino conditions. Okay, second large-scale climate-altering factor, explosive eruptions and comet and asteroid impact events. These events create so much dust, smoke, and other aerosols into the atmosphere. They throw them up into the stratosphere, and those small pieces of dust and smoke block out sunlight, cooling the Earth for months and even years. And here's an example. I already mentioned this in a previous lesson, how the eruption of Mount Pinatubo cooled down the Earth. You can see in the eruption data right here, the Earth's temperature cooled immediately after the eruption of Mount Pinatubo. And this is something that's been noticed for a long time. We talked about Krakatoa and Tambora earlier on in Unit 3 when we did volcanoes, and how they did the same thing back in the 1800s. So this ash eventually comes back to Earth, but it takes a while, and in the meantime it cools Earth down, blocking some sunlight. Third large-scale climate altering factor, the global ocean conveyor belt. This is a large conveyor belt of warm and cold water, and it has a lot to do with the salt-freshwater balance that determines how fast this thing's moving. And this is a planetary circulation pattern. It distributes heat around the globe. Now, one of the problems with the ocean conveyor, and let me just follow this so you can kind of see. I'll start off with starting in the Norwegian Sea, and it kind of runs, this is the cold current. It's very saline rich, salty. Salt water is heavier, more dense than fresh water. And that cold water distributes on the bottom of the oceans, whereas the warm water coming from the equatorial regions distributes warmer temperatures and more moist air around the globe. But the main thing about this that we really need to know is that if you alter the amount of ice at the poles, this melting and freezing cycle that the planet goes through, if you alter it by, for instance, melting off more of the Greenland ice sheets and the polar ice at the North Pole, that can change the salinity of the oceans and make it less salty in some areas, perhaps more in others. But that affects the speed of this global ocean conveyor, and therefore affecting the heat being distributed around the globe. And that can change climates worldwide. Now, some of the possible effects of that have been seen in the past. A long record of abrupt climate changes, and this is ice core data extracted from Greenland ice sheets, and it preserves the records of ancient air temperatures. And the records show several times when climate shifted in time spans as short as a decade. The Younger Dryas, about 12,700 years ago, the North Atlantic region dropped temperature abruptly. 5 degrees Celsius is a huge drop, and remained that way for over 1,000 years before warming up again. And you can see that change right here. Dropped right off, but then it did come back. And that possibly was due to this global ocean conveyor being altered. The 8,200 year event, similar abrupt change, not quite as severe. You can see right here that change. Lasted about a century. But if it occurred today, that would be catastrophic to growing crops, and there's a lot more people on the planet now. Where would they all get their food from? The medieval period, that was a warming period. That was responsible, and you can see it on the graph right here, for Norse settlements, from Iceland actually, to establish settlements in Greenland. Leif Erikson showing up in the northern coast of Newfoundland and then coming down to Vinland, as they called it, exploring way before Columbus came here. The Vikings were here. And then the Little Ice Age. And this caused those Vikings, those Norse, to abandon their Greenland settlements. It got too cold. They probably went back to Iceland. And this occurred about 700 years ago, between 1300 and 1850. And this had severe winter. This caused severe winters, and it affected lots of things, like political impacts in Europe, economic, agricultural. So all these things might have been affected by this global ocean conveyor. And all of this occurred before humans discovered how to unlock the energy in fossil fuels. So, this isn't caused by human pollution at all. Okay, another change, and this is a massive change. And it has to do with the Earth's orbital shape. We go through cycles where the Earth precesses or wobbles every 26,000 years, and our orbit literally changes shape and size slightly every 100,000 years. And when you put them both together, we get about a 100,000 year cycle of ice ages and interglacial periods. And you can see that in the graph here, where you get these periods of eccentricity change. And if you look at the time, they're about 100,000 year cycles. Okay, moving on to some human influence. So this is stuff that we're doing as a people on the planet to alter the climate. And one of them is really sad, deforestation. This is bad. If you look at the pictures on the left-hand side, you can see Borneo, an island in the Pacific. In the 1950s, looked great. 1985, starting to cut down a lot of forests. You know, people want their wood, they want their products, they want to raise cattle. And projected into 2020, you can see that there's less than half of the rainforest in Borneo that there was in 1950. You can see a picture down below there. This is the difference between forest and no forest. That's clear cutting. And you can see in the picture on the right how they're burning forests, they're clear cutting, and this is in South America. This is not good. Great quote here: destroying rainforests for economic gain is like burning a Renaissance painting to cook a meal. And that's from E.O. Wilson. Great quote, and it's so true. Okay, another human influence, urbanization. I paved paradise and put up a parking lot. That's the old Yellow Taxi song, redone by the Counting Crows. But, it's true. We're really changing our landscape because we're paving it over. And there's New York City on the left, an artist's rendition, before the humans came and built a city there. And there's Times Square on the right. Suburbia, is this really the American dream? And we can see all this natural rural area has now been converted or transformed into suburban and urban sprawl. Is this what America should do? Is this what it's all about? Now that obviously has effects on our local climates. You cut down a lot of trees, it's going to make the area warmer and drier. Those trees do help keep the moisture levels up and the ground cooler. And where's the life going to go? The life that used to live in those forests. This is a great shot showing the United States at night. You can see we're lit up. You can find all the major cities in the United States and even the small cities just by looking at the blobs. It's kind of fun to stare at this and pick out all your cities. Okay, the greenhouse effect. Now this is a natural effect, but there's some potential human-induced change here. And one of the things that's misconceived about this is the popular analogy that Earth's temperature is acting like a blanket to keep us warm is not right. Yeah, a greenhouse works. Sunlight penetrates the glass roof of the greenhouse and it warms up the air on the inside. But the glass ceiling really is shutting down convection, and that's why the air can't rise out and escape. So greenhouses really don't work like the greenhouse effect. Air doesn't act like a glass ceiling. There's no roof on the Earth's atmosphere. The real reason Earth stays warm is simply because air has a temperature. The Earth gives off, it radiates that heat that it's absorbed, heats up the air molecules can actually hold on to that heat. They get warmer. And some gases can actually maintain a higher temperature than others. They absorb a lot of heat. They have a higher specific heat, like carbon dioxide and water vapor and methane. And so that keeps us warm enough to have life on Earth. Now, there's controversy here because as we burn more fossil fuels, which make carbon dioxide, CO2, that human-enhanced greenhouse effect could potentially warm up the Earth. And that's what that right-hand picture shows versus the left-hand picture. So we got to remember the main greenhouse gases are CO2, methane, and water vapor is a huge greenhouse gas too because there's a lot of it. But it's not something that you're thinking of when you think of human-enhanced greenhouse effect. So remember, the greenhouse effect isn't really like a greenhouse. It's those greenhouse gases that are causing it. And it's actually a good thing to some extent. Without it, we'd be like the moon. We'd be really cold in the nighttime. Earth is like the Goldilocks planet. I always like to mention this. Just right, the average temperature is 59 Fahrenheit. Without it, without the greenhouse effect, we'd be -3 Fahrenheit. So we need that greenhouse effect. We need that warming effect. Mars is a lot colder because it has 1/5 of our atmosphere. So the atmosphere is what's helping us keep warm, just not like a blanket. Venus, much warmer. Venus is like the hothouse planet. It's got a real thick atmosphere. And so it has a greenhouse effect on steroids. Mercury's temperature is really warm too, but virtually no atmosphere, and that's simply because it's really close to the sun. All right, now, as the greenhouse effects kind of transforms into global warming, or global climate change as they now call it, and this is the projected increase in the average temperature of Earth in near surface and oceans since the mid-20th century, and projected continuation into the future, at least till the next ice age. And you can see the surface temperature record does go up, down during the summers, but overall the trend seems to be upward in this graph and upward in this graph. Now, there's a lot of controversy in this between different groups in the United States and throughout the world. And so really what we have to do is just always keep looking at new data. Ice age temperature changes over the last 450,000 years. You can definitely see we've gone through periods of warming and periods of cooling. Looks like those cooling periods last a lot longer than the warming periods, those ice ages. That's not good. But those are interglacial and glacial periods, those peaks and troughs. So the Earth's climate changes naturally, way before humans. Remember that too, that's really important to know. And this slide here, we kind of looked at something similar to this back a few lessons ago, but it just shows how the Earth's energy balance occurs and how, hopefully, our incoming 343 watts per meter squared equals our outgoing 240 plus 103 is 343. And if it doesn't equal it, if these are not equal, then the Earth's either going to cool or it's going to warm. And that's just common sense. And that's it for today, guys.